All right, so we said yesterday that double replacement reactions are double replacement reactions when the two parts of two chemicals switch around. Okay? Double replacement reactions, if we could give a general sort of form for double replacement, we could say we have some chemical that's in two parts, like A and B, and we could have another chemical that's in two parts, like C and D. And so A has to join up with D. Okay? A joins up, the front part of this always joins with the back part of that, and the front part of this always joins with the back part of that. Okay? Notice, this is really important. Notice, this is really important. The front part always remains a front part. A is always on the front, C is always on the front. Does that make sense? So whenever you're doing your predictions about the products over here later, we haven't gotten to that yet in this class, you know that the front parts always remain front parts. Okay? Kind of like you when you get dressed in the morning. Okay? Does anybody ever put on two shirts and no pants? No, you got to have a shirt and pants. Well, we got to have a shirt and pants for every one of these chemicals. And the shirt, did anybody ever wear the pants on their head? No, so the shirt has to go on your torso and the pants go on your waist down, right? So you got to put the right stuff in the right place here. Okay? Nothing more complex than that. Front parts are front parts, like your shirt's the top part and your pants are the bottom part. Right? Always got to be that way. You can switch them around. I can wear this shirt with a different pair of pants, but the shirt's got to go where the shirt goes, and the pants got to go where the pants go, just like these. Got that? All right? And that's not complex. Trying to make it that way. All right. But now, there's a sub-classification of double replacement reactions. A sub-classification called neutralization. And it's also called acid-base. Okay? Neutralization or acid-base. Both names apply to this classification. All right. So let's start with something really, really simple. How do we know when we got an acid? When you have a formula for an acid? Hydrogen on the front. If it's a non-organic acid, it has hydrogen on the front. So here's a real simple acid, HCl. We looked at that a while ago. It's on your worksheet for your homework for the lab. Okay? We're going to put it with a base. Now, something you don't know yet is that the simplest, easiest bases to recognize have it's an ionic compound with a hydroxide on the back. That's the easiest kind of base to recognize. So something like this. Here's an ionic compound with a hydroxide polyatomic ion on the back. That's a really easy base to recognize. Okay? Any kind of compound that has OH on the back is an easy base to recognize, well, except for water. Water is kind of a special category. Okay? You can write water HOH, same thing as H2O. All right? I'm going to show you that now. So, following this format then, the front part of this has to join up with the back part of that. So the front part of this is what? H. What's the back part of that one? OH, which we call, has a special name? Yeah, but what's the name of the polyatomic ion? I just said it. Hydroxide. Okay, so H has to join up with hydroxide, okay? HOH. What did I say about that? That's water. Okay? And then Na has to join up with, and which one do you write first? Na. Front part has to be the front part. Okay? NaCl. So this is a neutralization reaction because we're taking an acid and a base and putting them together and we're neutralizing it. We're making water. Okay? So neutralization and acid base are the same thing basically. Okay? Alright. But it works the same way as far as balancing and predicting as a double replacement reaction. But a neutralization reaction is always going to, I shouldn't say always. For us in this class at this time, we'll always produce water. That's only just for right now. Oh, I did this wrong. That's not AQ. You can't dissolve water in water. Huh? All right. So that's a subclassification for double replacement. Now, let's see. So let's move on then to the last classification that you need to know in this class. So we did single replacement, double replacement. Okay, this is one example of double replacement. We did the sub-classification double replacement. We did synthesis and decomposition. Those are 4 classifications we've done so far, plus this sub-classification we're talking about. And now we're going to look at combustion. Well, sometimes it's an explosion, but it can be just burning something. Okay? Actually, there are 2 kinds of explosions. Okay? There's deflagration, and there are explosives that are explosives in their own right. Okay? Deflagration just means a very rapid burning. It's rapid enough that it looks like an explosion, behaves like an explosion. So gunpowder, for instance, goes through deflagration. You have to have oxygen to make it work. But there are some explosives that don't require oxygen at all. So the chemical that's in your car that makes the airbags inflate, that doesn't require any oxygen. Okay, that just requires an impact and it explodes, and that's where you get the gases that inflate the bag. All right, combustion means, now there are actually lots of forms of combustion. We're going to simplify combustion down to one category of combustion. We're going to simplify combustion down to one category. Okay? Really, really simple. We're going to have some kind of hydrocarbon fuel. All right? Now, we talked about hydrocarbons in the last unit. We learned to name hydrocarbons. What is a hydrocarbon? What elements are in a hydrocarbon?
Hydrogen.
And?
Carbon.
Yeah, hydrogen and carbon. It isn't that hard, okay? So we have to have a hydrocarbon fuel. There has to be carbon and hydrogen. Now, the number of carbons and hydrogens can vary, okay? It can be different numbers. I'm going to put an X and a Y here just to show you can have a different number, okay? This is a general form. So the hydrocarbon fuel is going to react with this stuff right here. What's this stuff? Oxygen. And this is a gas. It's in the air. Okay, you're breathing it right now. Actually, you're breathing in a lot of other things, but you're only using the oxygen. On the other side of the equation, we're always going to be making the same products. Products don't change. It's always going to be, because we're doing real simple stuff here, CO2. What do you call that? What is CO2 called? Carbon dioxide. Okay? And then this stuff. Actually, I should make that a G. Okay? I know that one's hard to remember. Well, we'll talk about that. There's a reason why I listed it as a G this time. What do you know about combustion? Huh? Okay, well, I mean, just any kind of burning. What do you get out of burning? You get a blaze from it, so you get light. What else do you get? Huh? Can you stick your hand in it when something's burning? Well, you could, like Monty says, but if you did, what would happen? You get burned, okay? So you're not only getting light, you're getting heat, okay? Now, those are two other products. You get light and heat. Now, we generally, at this point in the semester, just kind of don't even worry about the light and heat part, but you need to know that you also produce light and heat in a combustion reaction, okay? Now, when we balance the equations, though, and predict products, we'll leave the light and heat off. You can put them on there, it's perfectly okay, but you don't balance light and heat at this point in the semester, okay? But you have to know that we can also produce light and heat. All right. The reason that water is a gas is because of this part right here, heat. It turns it into steam. You don't ever burn anything and get liquid water. There's too much heat. Now, it can condense when that water gets into the air. The cooler air cools it down into tiny droplets, and the white stuff you see is not gaseous water, but liquid water in tiny droplets. Okay, but that's not steam. Then it's water. It's condensed water. It's a cloud. Okay, the steam you can't see. Yeah. Initially, what initially comes off is water vapor. You can't see it. But then when it cools down and makes little tiny droplets, you can see the water, the light reflecting off of that. That looks white. So if you ever go down the road and you see a plant and you see white smoke coming out the top, that's not smoke, that's water vapor. Tiny little droplets of water. It's a cloud of water. It started out as steam, but it's cooling in the air around it and becoming that white trail of what looks like smoke. It's not really smoke. Okay? Smoke is actually particles, solid particles. Okay? All right. So this is the general form then of a combustion reaction. Hydrocarbon fuel, okay, oxygen gas. All right, those are reactants. This side is the reactant side. And then your products over here on this side always include carbon dioxide, and steam, or gaseous water. Okay? All right? So that's an easy one. This should be the easiest equation or reaction to classify. The easiest one to classify. Yes, ma'am?
This one's so, sorry. Is it always gonna look like CO2?
Always going to be CO2, always going to be H2O. Mm-hmm. Now we're going to have different coefficients in front, okay? But in general, you're going to have some C and H form here. That's your hydrocarbon fuel. You're always going to have O2 gas. That's always going to be that. You're always going to have CO2 gas. You're always going to have that. H2O gas. You're always going to have that. Okay? The only thing that's going to be different, other than the coefficients in front, will be which numbers go down here. Which subscripts go in the C and H formula.
Is it the C and H formula that the numbers contain in, right?
Yes.
Okay.
That's what it is. Okay? So, for example, if we have C2H6, okay, that's one of our formulas. Okay, that's a hydrocarbon. All right? So we put it with O2, and we get CO2, and we get H2O as a gas. That's really easy. You can predict the products really, really easy with a combustion reaction because you're always going to have hydrocarbon and oxygen. And if you have hydrocarbon and oxygen in this class, at this time, you can always predict CO2 and water. End of discussion. End of the story.
Combustion.
That's combustion. Classified as combustion.
Okay.
Now, I haven't balanced the equation. Okay? I've just given you a skeletal equation for the moment. Got that? Any questions? All right. No, a minute. You got the lab work to do. So I want to assign any practice work to tonight, because you got a lot of lab preparation to do. Okay. All right.
Thank you.
But we do have a couple minutes left in class. Why don't you guys take and try to balance this equation for practice? Okay.